In this talk, we will consider the usage of Python programming language as a tool for teaching science and mathematics. So our primary concern is science and mathematics and not Python. We'll start with something which we already know, that is the elementary algebra. And on the computer side, what we need to know is how to use a text editor and how to run the Python interpreter from a command window. So let us start the text editor. We are using Linux operating system, the Ubuntu distribution, and we are going to start the editor, say gedit. In this editor, let us type something which we already know, say x is equal to 5. This is your familiar algebraic expression, and you can also write something like this, y is equal to 4x. But here we have a problem. This 4x, there is an implied multiplication. 4x means 4 multiplied by x. But when you tell this to the Python interpreter, you have to explicitly specify that, say 4 into x. This asterisk or the star is the multiplication operator. And with this change, we come to the third line. Here we use, say, print x comma y. This is a Python statement, the print statement that will print the value of x and y on the terminal. So let us save this 3-line code into a file, say call it as say 1.py. See, we always give a .py extension, and once that is given, the editor knows it is a Python program and the highlighting is done accordingly. So next thing is we have to start a command terminal. Say we start ls terminal, from where we have to call the Python interpreter. Here is the terminal. So here we say call Python, give the file name as an argument 1.py. You see the result, x and y are printed. So now we'll go back and forth to modify this program and run it again. Say make it 4 plus x, save this, come here and interpret again. So the result has become 5 and 9. So what we have learned is just to implement an algebraic expression in Python. So now the question is, these x and y in a computer language, when you define a variable, it should belong to some data type. So what is it? It's an integer or floating point number or a complex number. How do we know? So let us ask Python. So we'll change the program again, say x is equal to 5, say print x, and we'll ask Python interpreter what is the type of x. Save this. So here we just clear the screen and run it again. It says it is an integer data type. How it is decided? Because you assigned an integer to x. Let us make this a 5.2. Save. Run it again. You see it has become a float type because you assigned a floating point number. Say make it something like this, 5.2 plus 3j, and obviously it has become complex type now. So Python uses something called dynamic typing. So you don't have to explicitly tell a variable belongs to some data type, so that's automatically decided. So we already seen 3 data types. Now let us introduce one more data type, say y is equal to, inside a single quote or double quote we type something. So now save this and run it again. So it says our y is a string data type. So you can see it's a character string, and you see that x and y, I mean the integer, float and the complex number, these three data types are slightly different from the string data type. The first three are numeric types and the string is a sequence type. You can see it's a collection of identical elements, so you can as well do some indexing. You can say the second element of y can be printed like this. So you can do indexing. So that means y of 1 means e, not the first element. First element you have to ask y of 0. Say y of 0, say it is h. Let us introduce one more data type, that is done something like this. Inside a square bracket we will type some elements separated by comma, and these elements could be belonging to any data type. And also ask what is this type. There is some error because here instead of x we typed y. So to correct this, but you can see here the Python pinpoints the error, say line number, and in that line number it just tells you where the error is occurring. So it's very error message is very clear. Name y is not defined. So after correcting, let us come back and run it again. So it says x is a list type data. A list means you can have the elements of the list defined inside two square brackets separated by comma, and here also you can do the indexing. You can type say x of 2. What it will print? It will print hello, because x of 2 is the third element, because 0th element is the first one. So what you have learned so far is, we learn how to define variables in Python. So simple, you just type something, a variable name, and assign a value to that, and that's all about it. And we also learned how to perform arithmetic operations, like here say x is equal to 2.3, say y is equal to x cube. So this 2 asterisks together is exponentiation operator. So this is x raised to 3. So you can print y. Run this. This is the result. So similarly there are several operators like our multiplication, division, addition, subtraction, and many other things are there, but we will not go into the details now. And one more thing you notice is, this program starts from the first line, then proceeds. That means it is executed in an order. So our knowledge at the moment is only this much. We know how to define variables in Python and perform arithmetic and logical operations, or not logical operations. That, let us put an example, something like this, say y is equal to 5 and x is equal to 2, and say print x is equal to y. This is a logical operation. It is testing whether it is equal to y or not. So the result should be false, but this is logical operation. See, this single equal sign is actually assignment operator, and equality is tested by this operator, two equal signs together. Or if you put something like this, this becomes not equal to, and if you try that, see, x not equal to y is true. Okay, with this knowledge, suppose say we want to do something like make a multiplication table of a number. Say x is equal to 1, say print x into 5. So if you execute this program, what it will print? So it is printing the multiplication table of 5, but this doesn't look like a proper way to do that. The reason is, at the moment we do not know how to change the program flow. It is starting from the first line and going to the last line. And to solve practical problems, we should know how to change the program flow. That means we should know how to use the control flow statements. And Python gives some control flow statements. One is for conditional execution and other for iteration or looping. Conditional execution means depending upon the value of some variable, it will execute one block of code or it will skip it. Suppose say if x less than 3, we put a colon, and after that, that block of code that is coming under this condition, under this block, say print small. Save. And if you run this, it will print small. But if say we make x is equal to 5 and run this program, there is no result, because when it tested this condition, it is false, so this is not executed. But we can modify this if, say something like this, else and another colon, print big or equal. Save this. Now it will print big or equal, right? So this is the conditional execution. What we need is looping. That means here it is executing once if this condition is true. But there are cases where we need to execute this block so long as this condition is true. So in that condition scenario, we have to use something like this. Say while x less than or equal to 10, say print x into 5, and we write x is equal to x plus 1. This means incrementing x by 1, right? Take the initial value of x, add 1 and put it back. So if you run this, you will find the multiplication table of 5. So what we have learned so far is how to define variables in Python and how to perform arithmetic and logical operations on that, and two control flow statements, that is the while loop here, while then some condition, and so long as this condition is true, this block of code under this while loop will be executed, and the blocks are just defined by shifting. That is how you say this block is under this while loop. And we can put another thing here. Suppose say if there is an if coming inside this, how it will behave. Say if x less than 5, print small. We'll save this and run. So that result will tell the meaning of that. You can see that here 4 times it was printed small. So when the loop started, first it entered here with x is equal to 1. This was true, and 4 times it is true. And later on, these lines, this print thing is skipped. So you see the result. So long as x is less than 5, it has printed small, and after that it did not print. Basically, this much knowledge is enough to solve small problems in Python. But our objective is mostly to deal with mathematical functions and manipulating big arrays of numbers. So we need something more to be learned. Suppose say I type something like this, sine of 1. Calculate the sine of 1 and execute that. Python says the name sine is not defined. It doesn't know how to calculate sine. So that means sine function has to be brought in from somewhere. The main advantage, or the strong point of Python, is the existence of a large number of libraries called Python modules for doing different jobs like scientific computation, networking, graphics and everything. Here we need to bring the math library, and the statement is from math import say everything. Now we save this and run it. You can see it works. So that means what we have done is we got the sine function from the math library, the math module. And what is a function? Function is a piece of code that is reusable and that does a specific job. And to explain it further, we can define our own functions. Just see what is a function. So I'll remove this and say def. So I'll make a function called myAdd, and there are two parameters, x and y, then again a colon, and this function is saying, say z is equal to 3x plus 4y and return z. And if I run this program, nothing will happen because we just defined the function but we did not invoke it. So now we say print my add, and here you give the parameters, say 3 and 2. So what it should print now? This 3 is the first argument that became x and 2 becomes y. So you can calculate what it is. So it's coming 17, that is 6 3 9 plus 8, right? So this is how you define a function, and the math library which we called has a collection of functions like this, so we just used it, that's all. And most of the time we'll be using these functions defined in the library, like again say type cos of pi, and where from this pi is coming? Pi is also defined inside the math library. Okay, now suppose we want to deal with a matrix or an array of numbers. How will you do that? So we have seen the list data type that can, you say you can define a variable like this, say 1 2 3, this is a list, and if I say print x into 2, what it will do? It made a 6 element list, and this is not something which we expect. What we want is this list, each element should be multiplied by 2. So that is the behavior we want. So for that reason we cannot use this list data type. So we need something called an array, and that is available from a module called NumPy. So we'll say from NumPy import all the functions, star means everything, And how do we define an array? And one simple option is here, say x is equal to array of, so you call the array function and the argument is this list. Okay, and now you can type something like this, save. Here you can see that each element is multiplied by 0.5, and this is the behavior we want. And now what is this type of x? Data type, it's a kind of array defined inside this, so it's numpy.nd array. We need not worry what it is, but that will do our job. And this is one way of making arrays, but NumPy gives a lot of functions that will allow you to make different types of arrays. For example, zeros of 3. And say ones of 5. You can see the zeros is making a 3-element array, and ones is making a 5-element array of ones, like this. And there are more useful functions, that is for, say, for example, defining a range of numbers, that is a range, say start from 0 to say 5, and you also have to give, say this is starting and a 0.5. Let's see what is the output. It gave something like this, starting with 0, and this is a step, say 0.51. It went up to 4.5. that means one step less than this endpoint. So that is how you define a range. So here you can say print x square instead of x. Save. See, it is the square of each element is the result. And there is another function, that is our linear space, that's called linspace here. Linear space, you can define something like this, say start point, end point, and the number of points in between. Suppose say put 10 points in between and print this x. So that means you start from -2 to 2. So you can imagine the number line probably. So it's 10 points, equidistant points, and if you want to make them slightly better, make it 11. Easy to understand. See, so 11 points from -2 to 2. This is the step of 0.4. It goes like this. So we have now an array of numbers starting from -2, ending 2, and 11 elements. And you can also print, say, x square see that this is our first array defined by linspace and the square of it. And we know that the y is equal to x square is a parabola. So suppose we add a line like this, y is equal to x square. So if we plot x and y, we should see a parabola. So how to plot it? So we need some other module for plotting. And plotting, the widely used Python module is matplotlib, and that can be imported using an interface called pylab. So this is one way of importing the plotting package, matplotlib. So you say simply, instead of numpy, I'm going to say pylab, import everything, and this imports numpy as well. So matplotlib and numpy comes. Now here I can just type say plot x comma y, and I have to add something like this, otherwise the program will exit before we see the graph. So this and here, so you have the result here. See, that is the parabola, and the graph, we have only 11 points, so you can see the graph is not very smooth. So let us close this and make more number of points and run it again. See here a smooth graph. And you can also specify in the one whether you want to put a particular marker, say plot have the plot here, right? So that means we have already learned how to use Python for plotting mathematical equations. So let us try some more equations like this. Let us take another linear space, say from minus pi to pi, right, and call say y is equal to sine x. So this should give us the sinusoid. See here the sine function. So similarly, any function can be plotted by giving the equation. Suppose say we want to plot a sine function for not single cycle. Suppose say we will put say 10 cycles, 5 cycles, 10 per, so save this. So you can see here there are several cycles, right? And now suppose say we need a sine wave that gradually decays. What should we do? We can just tell here multiply this with an exponential, say minus 0.5 into x. So that means a sine function multiplied by an exponential function. You can see that it decayed very fast, and make this 0.5 into say 0.2, save this and run it again. You can see here this is decaying slowly, and if you make this smaller, this decay will become still smaller, right? So these are some of the applications, and we can also use many other functions like this.